Everyone, boleh nampak? Okay, everyone. Assalamualaikum warahmatullahi wabarakatuh. So today I'll be talking about how we can design eco-industrial park planning towards net zero emission pathway. Okay. So I think all of you knows me. I'm an R&D manager for Process System Engineering Research Center inside UTM. And besides that, I also have a UTM spin-off company, which is called Optimal Systems Engineering Sdn Bhd. And I'm one of the director of R&D manager there. Okay, if you guys have any questions, feel free to ask anytime. You don't have to wait for me to finish. Yeah. So what I'm going to talk today, I'm going to talk about what is net zero emission and why we should go towards net zero emission. Yeah. In fact, in the latest engineering accreditation that we received, the visit for this year, they specifically request that the undergraduate now has to be embedded with net zero emission. In fact, they asked this net zero emission to be embedded into the curriculum for the upcoming students, right? So you guys are lucky. Net zero emission, as you guys know, is an upcoming trend nowadays, and it's very, very important for you guys to know what is net zero emission. So what is net zero emission? So I'll give a definition. I believe most of you already read about this and why we should go towards net zero emission. Okay. How do we go towards this? What are the country and industry role? Yeah, you guys will be a chemical engineer, inshallah. And then when you guys go to the industry, so you have to understand what is this net zero emission and how you can help your industry to achieve this net zero emission direction. I'll be talking about how we can achieve more. Yeah, how can we do integrated eco-industrial park planning so that you can achieve this net zero emission pathway. And I'll be talking about the relationship between eco-industrial park as well as process integration. Yeah, and I'll be talking about what are the universities' role to help in shaping this net zero emission so that more industries can go towards this direction in the future. Okay, so let's start. What is net zero emission and why we should go towards net zero emission? If you guys see, nowadays the impact of climate change is getting worse. Yeah, you can see that the previous flood, like for example at KL, even recently at Johor, the climate change is very, very bad. The flood is getting worse. Yeah, for example, was it Batu Pahat that was quite bad in the last flood in Johor, right? In fact, some other states also, Segamat, Batu Pahat, it was quite bad, the flood at that time. So the climate change impact is real. The climate change impact is real. In fact, now you can see all the heat waves coming in. The heat waves, the El Nino, and the impact is very, very severe. It can cause, for example, heat wave shock. You can die. Several kids, we can see in the news that people die because of the heat wave. Our temperature is getting higher. In some countries, it's even more than 40 degrees C. So all these are impact of climate change. And what is the reason that caused this climate change is, of course, the greenhouse gas emission. So we may be too late, but whatever it is, we should try our best to reduce greenhouse gas emission. If not, then the situation will keep on getting worse and worse. Yeah. So if you can see here, this is one of the report by the Center for Governance and Political Study. They say that 9 Malaysian cities will be underwater by 2050 due to the rising sea levels. And that's not far. Now it's 2023. It's just like 27 years in the future. Then 9 Malaysian cities will be underwater. So you can imagine that if this climate change continues, then there is a possibilities that some of our cities will be going underwater. You can find this report. They have a map in that report, and they show which cities in Malaysia that will be affected by this sea level rise and will be submerged under water at that time. So this is very, very worrying. And you can see that the impact of heat stroke, heat wave, is not just happening in Malaysia, it's happening all over the world, even in UK, in all Southeast Asia and others. You can see that the temperature is very, very high and dry. And if you don't take care of yourself, a heat stroke can happen, and many, many other bad things. And that's not about it. So imagine if we have a continuous drought in Malaysia. there's no rain, it's going to be very, very hot. Yeah. So if you see this Quran, yeah, this Quran, there's mentioned that kami turunkan dari langit air yang amat bersih, yeah, so that we can make the animals, the humans, and the plants, yeah, to live. Yeah. So rain and water is actually a rahmat from Allah. Yeah. So it means that if there is no rain and if there is a drought, then people, animals, plants, yeah, they can die without this water source. So this is a reality. If you read the news, they predicted that this heat wave, yeah, may even go up to August. Yeah? Imagine so long the drought might be happening. Maybe now we still have some more rain, but we do not know that maybe in June, July, August, let's say we have a continuous non-raining day. Yeah, so this could be a situation that is happening in Malaysia. And without water, it's not only plants will die, it means that it will affect our food supply. Yeah. So water, energy, and food nexus are actually very, very interconnected. If we don't have water, it might affect our food supply and also our energy supply. Okay. So you can see that plants will die without water, animals also cannot survive. Let's say we have less water in our river and our dams. Yeah? And you can also see that if without water, it will also impact all our commodities. Yeah, so you can see here, for example, to make one pair of jeans, you need 20,000 liters of water. And to make all these different types of food, yeah, that you guys are drinking, eating, and so on, everything requires water. Yeah? Even if you want to eat a steak requires 15,500 liters of water, which is enough fresh water to fill a small swimming pool. Yeah? So imagine if we don't have water, all the commodities will also be affected. Yeah? In fact, in some countries, yeah, like for example in Chennai, yeah, industries have to be shut down, yeah, because of this situation. So you can see that this is a possible scenario if we don't do something. Yeah? And in fact, on the power industries, yeah, many plants, yeah, in some countries, they have shut down because they don't have water. For example, in South Africa, North America, yeah, India, for example, they're using coal or natural gas, or maybe nuclear power plant. All these plants require water to be run. Okay, so without water, again, will have an impact on our energy supply. So imagine at that time, now you still have aircon. Yeah, now maybe you can still have water purifier at your home. Maybe in the future, if the energy is also impacted, then it means that there's no electricity. We may have power cuts. Yeah. So in that situation, again, maybe we can't even enjoy aircon and so on, even on a very hot day. Yeah. So those are possible impact of climate change. So you can see that is why people say that food, energy, and water. Yeah, so they call it the food, energy, and water nexus or fuel. They are all very, very interconnected, related. If there's no water, it will impact your energy and food security. Yeah, if there's no energy, also you cannot produce clean water. Yeah, and you cannot also produce the various type of food that you have nowadays. Yeah, so everything is interconnected. Okay, so let's go back to what is net zero emission. Yeah, why we should go towards net zero emission. So according to the United Nations, to keep the global warming to no more than 1.5 degrees C increase, yeah, we need to reduce our emission by 45% by 2030 and reach net zero by 2050. Okay, so what does net zero means? Net zero means, first of all, you have to lower your greenhouse gas emission as much as possible. But of course, you cannot go up to zero. Yeah. So because of that, we have to remove the emission. So to remove this emission, we could use, for example, forest sequestration. We could use carbon capture and sequestration and other ways. Yeah. So when we have tried to minimize, and then we still have some CO2 or greenhouse gases that we cannot reduce, then we have to remove it, yeah, by using certain technology, certain ways like sequestration. So the net zero means after we have reduced by sequestration, then it becomes net zero. Okay, so net zero doesn't mean zero emission at all. It means that we have minimized our emissions and the remaining emissions is being absorbed by the forest or being sequestrated by converting it into other products. So that is net zero, and our goal is actually to ensure that we can reduce this GHG emission by 45% in 2030 and net zero by 2050. Okay, how do we go towards net zero emissions, and what are the country and industry roles? If you see here, more than 70 countries all over the world that have pledged for net zero emission target, including China, United States, and so on. And even Malaysia also has pledged to go towards this net zero emission in 2021. So Malaysia has also pledged that we will go towards net zero emission by 2050. And this one is by the recent government. Of course, this one is the previous Prime Minister. Even the recent government, they also said that they are still pledging that Malaysia will go towards this net zero emission by 2050. So we cannot run away. We as a student and you guys as a future chemical engineer, you guys have to know how you can help industries to achieve this net zero emission direction. And net zero is being, people are asking, people are creating awareness. For example, in the IEA report, they created a global report and suggestion on how the whole world, the whole industries, states, and so on, they can move towards this net zero emission. So they have come out with a blueprint on the directions on how countries as well as industries can move towards these net zero emissions with various strategies and technologies that they have already listed down. You can read this report if you're interested. And if you look at countries, industries, so just now I was talking about countries, this one are industries. So over 200 companies have already pledged towards net zero emission by 2040. Because nowadays, if you heard, one of the buzzword is ESG. ESG is environmental, social, and governance. So many companies nowadays, they are being pressured by this ESG requirement and towards net zero emission. So even though they are just a small SME companies, but if they're the company that they, let's say they sell their product to a big company. So if that big company, they have a direction that they are going to net zero, and then they require, for example, their suppliers to also have this greenhouse gas direction, then all the other small companies have also to follow through. So you can see that this net zero emission, many industries are going towards it. So including Petronas, you can see here, Petronas, TNB, Nestle, Kaneka, BASF, Shell. You go to their website and you're going to see that most of these companies, they have this net zero emission pledge as well inside their website. So how can we reduce carbon emission? How can we reduce this greenhouse gas emissions to the atmosphere? So typically what we can do is we can use this carbon management hierarchy. So what is carbon management hierarchy? Basically you start from the top. So it's a triangle which is upside down. So the top one is our main priority, and the bottom one is the one that we should do it last, after we have done all the other measures. So the first thing that we always have to do is to avoid. How do we avoid and how do we reduce? This is why, if you guys remember, we do the value chain analysis. First thing, we try to develop, for example, a reaction. We choose a reaction path that use less energy in the first place, for example. And if it can be even like zero energy, that's even better. So the first one is always we try to avoid. How do we try to avoid? We choose a reaction path that has less GHG emission. That was the reason why in you guys, the first Verbund project, you do the reaction path analysis for your value chain, and you also do the carbon footprint, right? So for example, let's say you have 3 possible reaction paths. So which reaction path besides is the most profitable, which one is also advantageous in terms of the less greenhouse gas emission that is being emitted. So this one can be measured by using, for example, carbon footprint. Okay. So how to avoid and reduce? Normally it's demand side management. We can change the mode of operation. We can go for energy efficiency and conservation. Yeah, so there are many technologies out there where you can do energy efficiency. Yeah, you can choose a more energy efficient equipment. Yeah, you can choose an equipment that can recover waste heat, for example, and many others. So the first strategy is always to avoid, followed by reduce. Yeah. So once we cannot do that, then we have to substitute. Yeah. So people sometimes argue, yeah, should we always go for renewable energy? Yeah, like solar PV. Yeah, most of the companies you hear, they want to go towards renewable energy. But renewable energy is, of course, one of the strategy to reduce greenhouse gas emission. But our first strategy is always to avoid and reduce first. Then the remaining, if you still need energy, you choose energy which are cleaner. Yeah? So in this way, then this is where supply side management comes in. It's always at the third level. So always go for energy efficiency and avoidance first, followed by changing to renewable energy. Yeah? Because you imagine, yeah, let's say you install solar PV, but you are not energy efficient inside your home or your company. So let's say if you are not energy efficient, you consume 1 megawatt of electricity. Yeah, so you have to have a solar PV which can produce 1 megawatt of electricity. But what if you reduce first? So you only need 500 kilowatt of electricity. So in that sense, you only need to have a solar PV which can produce 500 kilowatt of electricity instead of 1 megawatt of electricity. Yeah, so it's always better to reduce first before we go for supply side management. So this one is also known as demand side management for the energy efficiency part. And supply side management is where, let's say you are using electricity, then maybe you can consider solar PV, wind energy, or other types of renewable. If you're using thermal energy like steam, yeah, maybe you can consider biomass or other types of sources. Okay. So once we have already managed our demand and we have already managed our supply, then the next thing is the remaining greenhouse gas, yeah, because we cannot go towards zero. Even though we install solar PV, maybe we only have certain amount of rooftop. So you cannot go until zero electricity, for example, right? So we still have some emissions, yeah, some emissions from our companies, from our homes, and from other places. So what can we do next? This is where the next part is the end of pipe management. Okay, so the end of pipe management is where the remaining greenhouse gas, we try to see how we can convert it into another product. Yeah, so that's why I asked you guys to look into carbon capture and utilization previously. Remember, in the last semester, some of your team, you have to consider what to convert the CO2 to. Yeah. So here, when we want to convert, first thing is we try to convert CO2, for example, into another product. Yeah. The next thing is, if you cannot convert it into another product, then you have to think about sequestration. Okay. Sequestration means, for example, you inject it down the enhanced oil recovery, and you use this CO2 to push the oil out instead of nitrogen. Okay. So that is sequestration. So there are many strategies for sequestration, and is the fourth level after you have done demand and supply side. So the remaining you have to do end of pipe management. Yeah. And for example, yeah, let's say you don't have this sequestration technology. Yeah, nobody wants to buy your CO2. And then let's say there is an enhanced oil recovery, but it's very, very far from your company. Okay. So what to do next? How do we get this net zero direction? Yeah, so that's where the last level is what we call offset. Yeah, so offset means we cannot reduce. So what happened is other places reduce the emission and we purchase the carbon emission reduction from them. So when we purchase carbon emission reduction from them, we call this carbon credit. Yeah, so this is what we mean by offset. So these are the 5 strategies to achieve net zero emission. So talking about carbon offset, if you want to know how to trade carbon, yeah. So basically, if a company reduces carbon emission, you can actually convert that reduction of carbon emission into a carbon certificate and sell it to other companies. Because some companies, as I have mentioned just now, they have to go towards net zero, like Petronas, Nestle, TNB, and many other companies just now. They have to go towards net zero, and not everyone they can go towards sequestration, because one, the technology is not everywhere yet, and even though they have the Kawasari plant where you can already sequestrate, but that's only at one location, and it's going to be very far for you to transfer your CO2. So let's say your plant is several kilometers away, maybe 200 kilometers away from this site. So it's going to be very expensive for you to send your CO2 from your plant to that enhanced oil recovery area. Okay, so in that sense, that is the reason why people have introduced this carbon trading mechanism. Okay, so carbon trading for Malaysia is voluntarily. It's voluntarily, and they call it the voluntary carbon market, VCM. So basically, you can purchase this carbon certificate, which is being sold by Bursa Malaysia. So Bursa Malaysia, they have this what they call in English is lelong. Basically you can bid to purchase this carbon credit from Bursa Malaysia. So this is a new scheme being introduced this year. So you can purchase this carbon credit. So if you guys are planning this net zero emission for your Verbund plant, so remember the carbon management hierarchy that I showed just now. Go for avoid. So you guys have to explain from this 5 angle how you guys go towards net zero emission. First, go for avoid and reduction as much as possible. Next is plan your supply side management. Fourth is look at your end of pipe management, which is your waste and emission management. And fifth, if you still cannot go towards zero emission, you have to go for offset. So maybe you have to check what is the common price of buying a carbon credit. So from there, you can input it as another cost inside your plant design. So let's say you are doing your Verbund calculation later on for profitability analysis. So you cannot go towards zero emission. So when you guys calculate your Verbund plant emissions, it's still not zero. So what you can do is you can go for offset. So you have to do your planning on how you guys can achieve net zero emission for your Verbund plant. Okay, so how can we achieve more? If you guys see the pledge that I show you guys just now are mostly by single company, like Petronas, Nestle, TNB. But if we work in silo, that is where you cannot do much. So for example, let's say Nestle, for example. Nestle, for example, even though they have reduced their carbon emission as much as possible, but then they don't know where to sell that CO2. They still have some remaining CO2, and they don't know where to sell that CO2. That's where we can work in synergy. The idea of the Verbund plant being introduced in this program is to teach you guys that we can work in synergy with other industries nearby, right? So this is where the Verbund plant comes in. If you guys still remember, this is a linear system plant where you consume natural resources and utilities like electricity, water, and so on. And every plant produce their own waste, and of course they have product and byproduct. But in a circular economy, if we have a waste, like CO2 or other types of waste, and there are other plants within that area that can use this waste and convert it to resources. That is where the concept of circular economy comes in. That's why people are talking about circular economy, industrial symbiosis, eco-industrial park, net zero emission nowadays. So this is industrial symbiosis, and again, this is what we want to do in our Verbund plant. That's why in the first place, again, we do the value chain analysis because we want to find the possibility of which plant that can be connected to each other to create this industrial symbiosis system. So how do we create industrial symbiosis if we work together in synergy, right? So imagine first, just now it was a linear system, one industry you utilize some utilities, and then you emit waste, and of course you get your product. Yeah, but imagine now, so if you work single, if you work individually without working with other industries, so you can do demand side management. Yeah, of course you can reduce, you can do energy efficiency, you can install solar PV, but there will be just as much as that, as much as you can do. Yeah, because you cannot go net zero normally. Yeah, but if we go for industrial symbiosis, working with other industries, then we can exchange the remaining waste and emission to those that can buy and utilize it. Yeah, so this is where industrial symbiosis come in. And here is where we would like to introduce to you guys the industrial symbiosis or eco-industrial park design between process integration. Okay. So here you can see that this one is demand side management, where typically companies, they can also exchange their waste and resources with other companies. And here we have supply side management. Yeah, so for example, each plant needs electricity, fuel, and so on. Of course, you can install solar PV by yourself, but you can also look into centralized system. Yeah, if you do it by yourself, yeah, of course, you have some limited roof area, for example. And if, for example, you use thermal, yeah, thermal like steam, hot oil, and so on, and you want to use biomass. But the problem is sometimes biomass steam system, you require a big space, yeah, because one, you have to store your biomass. Yeah? Imagine you buy a shell or empty fruit bunch from palm oil. So if you buy this biomass, you have to store it somewhere. So the storage will be big. And then after that, you have your biomass boiler. Again, you need a space and area for this. And biomass, if you burn it, it's not that clean, yeah? The moisture content is very high, it got sulfur, and it got many other impurities inside the biomass. So you need to have some cleaning. You need to clean the gas that comes out from that biomass system. You need to manage the ash, and there are many, many other things. So to install a biomass system, for example, it requires a very huge amount of space, and you also need to get special permits, yeah, from DOE, yeah, in order for you to install this biomass plant. So not all companies, they have this available space. Yeah? In fact, you have to think how to get this biomass supply within Malaysia. Yeah? So it's not that easy to get biomass supply, and you have to get it continuous biomass supply. So you have to find a reliable source that can continuously give this quality amount of biomass. And biomass, because you know that it's a plant, so it have different quality and different problems when you're managing it. Okay, so it's very, very hard if you are to do it individually as an industry. Yeah, so that's the reason why many companies, they are moving towards this centralized utility planning. Yeah, either you want to centralize your biomass plant, and then after that, maybe that steam being generated by that centralized biomass plant, you can use it by several industries nearby. Yeah, so that's why nowadays there's a lot of concept where people create a biomass plant or maybe a solar plant at one industrial area, and then after that they sell this steam electricity to the plants. Yeah, because this plant, they want to go towards net zero, so they want a greener source, but they don't have enough space as well as manpower within their company, so it's better for them to outsource. So this is where businesses can comes in as well. Okay, so supply side management, of course, you can do individually for each industry, but sometimes, as I mentioned, there are a lot of limitation in terms of manpower, space, and so on. So people go towards centralized direction. Yeah, and in centralized, sometimes you have the experts that can do that, and you get the pool of economy of scale. Yeah, so there's a pro and cons in this. So in supply side management, you can go towards a more greener fuel, yeah, either for electricity, solar, biomass, and so on. And you can also share resources so that you can reduce the cost and so on. Yeah? So that's the reason why in this Verbund plant, we also taught you guys about centralized utility system, yeah, and what's the benefit and so on. And finally, yeah, of course, you need utilities in your plant. The next thing is all the plants also produces waste. Yeah, so you need to do your end of pipe management. Yeah. So the end of pipe management, you guys remember, you did your centralized waste treatment system, right? So what are the wastes coming out from the industry? Yeah, so it's like gas emission, you have your wastewater, you have your solid waste, you have your hazardous waste, and you have many, many other types of waste coming out from your industry, right? So what can we do with this? So we have to do either treatment, yeah, we have to do landfill, maybe some of the things you can incinerate and generate energy. And you should also consider recycling, yeah, reusing, yeah, utilizing it, converting it into other products, as well as sequestrating these emissions. Yeah, so this is where you are at the sequester stage. So in an industrial site planning, these are the things that we want to look at. And if possible, we don't want to work alone. We want to work in an industrial symbiosis condition. Okay. Okay. So moving on, that is where integrated eco-industrial park planning has a major role, yeah, towards this net zero emission. If we work in synergy, we can achieve more. Yeah. And what is eco-industrial park? Yeah, so they don't call it Verbund. Yeah, Verbund is a term from Germany, which means integration to the maximum degree. But if you go to other countries, a more common term for Verbund is actually eco-industrial park, right? But eco-industrial park, yeah, so for example, in Malaysia, there are many industrial sites that claim they are eco-industrial park, but they actually do not follow the spirit of the eco-industrial park in total. Yeah? So not all eco-industrial park, even though they claim that they are, but not all park do this industrial symbiosis. Yeah, but there are, of course, some EIP, yeah, eco-industrial park. In short, we call it EIP. There are some of these EIP, like in Korea, in China, yeah, and Germany, and so on. They do have this proper eco-industrial park. So eco-industrial park, they have several levels. So they're classified as level 1, level 2, level 3, and so on. So for example, if you're just at level 1, yeah, maybe you're just a green park. If you're at level 5, for example, then you already have this industrial symbiosis, circular economy, and so on. So even though many sites claim they are EIP, they're also being classified at which level of EIP that they are at. Okay, but a proper EIP should have this industrial symbiosis working inside the plant, the industrial site area. They should have the supply side planning going towards net zero, demand side planning, as well as the end of pipe solution. That is a complete eco-industrial park moving towards the level 5, yeah, direction, where if you read the eco-industrial park guideline for Korea, for example, they mention about what are the criteria of a good eco-industrial park. Okay, so this one I have shown to you guys previously. This is an example of Kalunberg Eco-Industrial Park, and you can see that how, yeah, they connect among their industries in terms of energy, in terms of water, as well in terms of material. Yeah, so you can see how they're being connected, and they save about 24 million euro for this company. They reduce their CO2 about 635,000 tons. And also water as well as energy. Yeah? So there's a lot of benefit that they gain from this eco-industrial park. Okay, and these are guidelines. So if you go to the this guideline by United Nations, UNIDO, yeah, so they have a guideline on how to create eco-industrial park. So according to the World Bank also, currently there are only about 250 EIP, yeah, globally. And Malaysia is one of the countries that are looking into developing EIP for Malaysia. And this is done by SIRIM as well as MITI. Yeah? So SIRIM and MITI, they have this initiative where they would like to develop an eco-industrial park in Malaysia. Yeah? So I did some projects with SIRIM. Just recently, I have completed a project with for a sugar refinery. Yeah? We did a project for 2 sugar refinery in Malaysia. So in that sugar refinery project, we identify what type, how to increase the energy efficiency as well as how to improve the resource efficiency of the plant. And we also propose industrial symbiosis mechanism for that sugar manufacturing plant. Yeah, so SIRIM has engaged us for several project. So I have done for sugar plant as well as for palm oil plant with FGV as well, yeah, Felda Global Venture. So this one is a real thing, yeah, and it's in demand nowadays, yeah. So circular economy is also an in thing. Yeah, it's not only in Malaysia, Vietnam, Indonesia. Yeah, all the ASEAN countries. Yeah, they're also moving this circular economy and EIP. Not only Malaysia. So we are actually quite late. Yeah, in fact, when I read the newspaper article, I think Indonesia and Vietnam is far more ahead. Yeah, compared to Malaysia. Malaysia is quite slow in terms of initiative on this. But other countries, yeah, they are moving very aggressive towards this direction. So Malaysia should not be left behind in this. Yeah. So eco-industrial park is the future, and we should learn. Yeah, that's why we are learning this in this plant design project. Okay. Next one I want to talk about eco-industrial park planning via process integration. Yeah. So you guys have learned previously heat integration in your plant design one, right? So you also have done it for your design project. So how can we use this? So process integration is actually not only limited to heat integration for single plant. Yeah, process integration has actually expanded to many type of resource integration, and you can do process integration for single plant planning as well as for eco-industrial park planning. Yeah. So I'm not going to teach the whole method here. I'm just going to introduce to you guys the available process integration method for eco-industrial park planning. Okay. So what is process integration? Yeah. So you guys have been introduced to this process integration last semester, where you learned the first method of process integration, which is heat. Yeah. So process integration was born in 1970s, yeah, when they introduces heat integration. So that was the first process integration technique being introduced, and it was used to maximize the energy recovery for a single plant. Yeah, so it was introduced by Linhof March in 1970s because at that time there was an energy crisis, and energy price was very high at that time. It's just like nowadays, because of the Russian war, the natural gas price is very high, right? So that was also one of the trigger at that time. Natural gas was very high. So that was the reason this heat integration booms at that time. But so what is heat integration? Heat integration is a systematic technique for the optimal design and retrofit of process system for maximum heat recovery. Yeah, so it's what you guys have learned last semester in your plant design one. Yeah, you do your energy targeting, follow your by the network design. Yeah, but process integration is much more. It's about resource integration. Yeah, it's not about just recovering the heat. Okay, so in a process integration, they look into how to integrate all type of resources within a single industry as well as for multiple industry. Yeah, it looks into circular economy, recycling and recovering economy. Yeah, but all of them uses the same concept. Yeah, so process integration, one of the main concept is that they have a source and a demand. Yeah, so for example, in the case of heat integration, you have hot stream and you have cold stream that you can exchange the energy, right? And then in process integration, you have what we call pinch. Yeah? So pinch is a bottleneck of the situation. So if you find the bottleneck, then you can find the maximum target that you can reduce your energy target, for example. So process integration for all type of resource, they have this same concept. Yeah, you have to have a source, you have to have a demand, and they will identify the pinch point or the bottleneck of the situation so that you know what is the maximum resource target that you can get. So that is basically what is process integration, where you can target any type of resource integration as long as you have a source, a target, and you can find the pinch or the bottleneck of the system. Okay. So you can see here, these are actually the history of process integration. So initially it started with heat integration, but then it was expanded to mass exchange network. This is for solvent recovery. Yeah? In your plant, you use a lot of solvent. Yeah? So for example, you have an azeotropic distillation column. So in an azeotropic distillation column, you use solvent. Yeah? In fact, when you have an absorption column, yeah, you also need solvent. Yeah? So mass exchange network is where the waste solvent, they try to recycle and reuse it as much as possible before they throw away the solvent. Yeah? So they try to maximize the amount of load being absorbed by that solvent before it is being discarded. Okay. Then people introduce water integration, total site integration, where they do not only for single site, for single plant, but for multiple plant. They have hydrogen pinch, supply chain heat integration, CO2 integration, power pinch, power integration, waste integration, and many, many more. Yeah? So in fact, the trend is just so much nowadays, but basically it covers various type of resources. So from previous definition of heat integration, nowadays resource integration, the definition is basically a systems approach for the holistic planning, design, and retrofit of optimal resource utilization systems and network. Okay, so our research center, so I'm also a researcher from Process System Engineering Center, or in short, PROSPEC. Yeah, so this research center is at Block N29. Yeah, so our research center has more than 20 years experience in this kind of resource integration. Yeah, in fact, if you just try to find the papers, yeah, so we have done not only for heat, we have done for power, water, waste, low CO2 planning, net zero emission, and so on. So if you are interested, I can also share you the papers on the research work. Yeah. So we also have books. Yeah. If you're interested, you can also find these books in the library. Yeah. So we have books on how to do resource integration for various type of resources. So maybe next time, yeah, when you guys are working, yeah, maybe we're not asking you to integrate all types of resources in this Verbund plant design project. Don't worry, but I'm just giving you some overview, yeah, about what type of resource integration technique that is available out there. And if you are designing a real eco-industrial park, or maybe you are designing some zero emission, yeah, in the future for your company, yeah, so you can also look into these other reading materials. Yeah, so me as well as my colleagues, we have published a lot of journals, books, yeah, in this area. And if you're interested, you can read on all this technique in these books or journals, as I have mentioned. Yeah. So why process integration? Process integration is quite an established technology. Yeah? As I have mentioned, it was introduced long in 1970s, and it has been used in various industries. Yeah? So when you guys were doing the targeting and network design that you did in your class previously, that technique is actually being used worldwide and globally by various countries. Yeah. So if you see that even if we are doing retrofitted project, yeah, meaning existing plant, and you are doing heat integration, so there is actually a different technique for retrofit heat integration. Yeah. So you can see that the range of energy saving, yeah, is between 10 to 40% or 10 to 60% if in terms of heat recovery, if you recover the heat within your processes. Yeah. So water also, yeah, these are some projects of water integration that we have done for several companies. We have done analysis for MIMOS, semiconductor plant. CCM is a chlor-alkali plant. Yeah, we have also done analysis on Sultan Ismail Mosque in UTM, as well as a Malaysian paper mill plant. Yeah, so you can see that if you do water integration, yeah, you can almost reduce the fresh water requirement inside the plant, yeah, by even up to 95%. Okay. Okay, so these are some real savings of energy that we have done for many, many companies. Okay. So besides that, our research center, we also have software. We have software called Optimal Heat, where you can do the things like the heat pinch analysis that you are doing manual calculation. We have this software called Optimal Heat, which can do all this automated design for you. And we also have what we call optimal water that can do water integration. Yeah, so our research center has also developed for total site heat integration and many other resource integration technique and software. Okay. And we have a specific training. Yeah, so as I have mentioned, we're not going to teach everything here, but we have a certification for thermal energy recovery expert. Yeah, so this is a certification program which is done by our spin-off company, and we call it the thermal energy recovery expert. So if you're interested to learn in more detail on advanced heat integration, yeah, you can also look into this workshop that we have. Yeah, maybe in the future, not now. Yeah. Right, so let's go move on. What waste or resources can be integrated and in industrial site using the various type of process integration method that I mentioned previously. So I'll give you guys an overview about the different type of process integration method, how it works basically, yeah, and how you can use it to improve your eco-industrial park planning. So what type of waste or resources that you can integrate for your eco-industrial park? You can do for heat and power system, you can do for your wastewater system, and you can also do for your CO2 emissions. And of course, waste also, we can do waste management planning by using process integration. Okay, so how do we use process integration for all this? Okay, so process integration for eco-industrial park planning. Let's go for the first one. How do we target the heat and power system, yeah, across multiple sites? So previously you have learned about heat integration for single plant. So how do we target for multiple plant? Okay. So this concept of heat integration for multiple plant, we call it the total site heat integration. Yeah, total site means the whole site. Yeah, the whole industrial park, for example. So how does it work? Yeah. So for example, this is plan A, plan B, plan C, and plan D. Yeah. So first thing is always you want to maximize the energy recovery within the plant first. Yeah. So this is where you implement your single plant heat integration that you have learned last semester. Okay. So after all this plant, they have already maximized, yeah, the energy recovery, and but they still need some steam, they still need some cooling as well as heating utility. Okay, so that is where we use the grand composite curve, yeah, like the lecture that I have also attached in the e-learning. Yeah, so they use the grand composite curve to determine what are the remaining heating and cooling utilities that they require. Okay, so in a total site heat integration, there are also some plants that have excess heat, which previously they need to cool down. Okay, so instead of they have this excess heat, which is high temperature, and they have to cool down, for example, by cooling water. So that is actually a waste of heat, yeah, because they say, I don't need this heat, but there's nowhere else inside my plant that I can use this heat or energy. So I have to cool it down. I cannot just release a very high temperature heat to the environment. Okay, so in that way, this very excess heat, you have another alternative. Instead of cooling it down by using cooling water, you can generate steam and you can sell it to another plant. Okay, so the idea of total site heat integration is not only to have a centralized utility system. So you can see here we have a centralized utility system where I have a boiler that is producing steam, and then I produce various level of steam, which are high pressure steam, medium pressure, and low pressure steam. So this centralized boiler, typically I'll be producing this very high pressure steam, and then I'll be stepping it down by using a turbine so that I can also generate electricity at the same time. So we call this combined heat and power system. So instead of stepping down by using valve, so basically to step down my steam to the required pressure by the companies, I have two options. Yeah, one is to use valve, yeah, PRV, pressure reducing valve. Like for example, here is an example. I produce very high pressure steam from my boilers, and then I step it down by using pressure reducing valve to high pressure steam, medium pressure, low pressure, and so on. I have another alternative. Instead of losing the energy, yeah, because if I release the pressure, I lost my heat to the environment. Instead, I use that energy to rotate my turbine, and I can get electricity at the same time. So that's a combined heat and power system or cogeneration system. So by using a turbine, I get the same impact. Yeah, I can reduce my very high pressure steam to high pressure, medium pressure, or low pressure. I can step it down. And at the same time, I get electricity at the same time. Yeah, so it's always beneficial to have a cogeneration system if you need to step down your steam to several levels. Okay, so if you are doing centralized utility system planning for steam, for example, you may have considered this system, yeah, where you have a centralized boiler which can step down by using either valve or cogeneration system. And this steam, so you have a high pressure steam header here, medium pressure steam header here, low pressure steam header there. So your boiler, you feed the steam to these headers. And then after that, this steam is being utilized by the different plant. Okay, so this is a common centralized utility system. Your centralized boiler produce steam, step it down to the required pressure, then send it to the plant that require the steam. Okay, what is total site heat integration? The total site heat integration, it has two-way direction. Yeah? Instead of the centralized boiler only feeding the steam to all industries, industries that have excess heat, yeah? Like the one that I mentioned just now, this, for example, let's say this company, they have this high temperature heat that they still need to cool down by using cooling water, and they cannot utilize it in their own plant. Yeah? So what happened is they can generate heat from that process instead, and they can also sell it to this header. Okay, so that is total site heat integration, where besides centralized utility system, the companies, yeah, if they have excess heat and they can also generate steam, they can also sell to the centralized utility system. So it's a two-way direction. Okay, so that is total site heat integration. Basically, you can produce steam from your centralized boiler, as well as other plants can also buy and sell the steam from their company. And besides that, they can also buy and sell electricity. Yeah, so here you can see that your cogeneration system produces electricity, which is again being supplied to the plant. And let's say each of these plant, they have a solar PV, for example, at their own company. They can also sell their electricity to the grid. Okay, so this is the concept of total site heat and power integration. And the remaining heat which cannot be reduced, yeah, from this total site integration, then they will cool it down. So what is the benefit of this total site integration is that you can reduce your centralized utility system fuel requirement. Yeah, before this, you need to generate a lot of steam to feed to all the companies. Yeah, so meaning you have to have a very big centralized utility system boiler. But now, when you have other plants as well feeding steam to the header, so you reduce your capacity that you need to design for your centralized utility system. So in that way, you reduce the cost of your centralized utility system design when you can also purchase the heat from the other plant. And another benefit is these other plants, they can also reduce their cooling water requirement because now they can generate steam, and they can also have income generation. Yeah, because now they can sell some of their steam and electricity also to the headers. Yeah? So it's just like when you install solar PV at your home, you have excess electricity, you can also sell it to the grid. So it's a two-way direction. Okay. Any question so far? All right. If you guys have questions, feel free to post it in the chat and I'll be happy to answer it. Okay. So far, so good. Yeah. Okay, moving on. How do we do this total site heat integration technique? Yeah, so there's actually another composite curve where we call it the total site heat integration technique, where it has two types of new graph. Yeah, so they have these two types. So this is a source and sink composite curve. Yeah, so it uses the same concept as the composite curve that you guys have learned for single site, but this one is for multiple site. Yeah, so basically it gather the amount of heat source as well as heat sink available at all the plants inside the industrial area. And then they say this from that heat source. Yeah, heat source means they still have excess high temperature heat, which they need to cool down from all the companies. So they analyze in terms of the quality of the heat or the temperature of that company temperature that they have in their process, remaining process. Okay. So from there, they see if there's possible to generate steam from all this excess heat from the plants. Yeah. So then they also look at the demand. Yeah, let's say you have 5 companies in the eco-industrial park. What are the demand for the different types of steam or different types of utilities? And then from there, let's say this is the generation that is possible to be generated from the existing plant. And these are the requirement or the consumption of steam needed. So they try to merge the two composite together. And then they see what is the remaining steam that is still needed to be generated by the centralized utility system. Yeah. So basically here, when you put the two curves together, yeah, so you have Q recovery. So this is a total site heat integration. Yeah. So this is heat source, this is heat sink from all the multiple plant. Put the graph together, so you'll see that these are the remaining very high pressure steam that you still need to produce by using the centralized boiler, and these are still the cooling utilities that you still need for your cooling water system. Okay, so that is total site heat integration. If you guys are interested in total site heat integration, you can read this article by Clemens et al. 1997. So this is the name of the article as well as the journal paper. Yeah, so they explain how to do this total site heat integration. Okay, so total site heat integration, they also have 2 types of technique. Yeah, they have the graphical technique as well as they have the numerical technique. Yeah, just like you guys learn your heat integration, you have your composite curve as well as you have your problem table algorithm, right? So for total site, it's the same. They also have this graphical technique, which I have shown just now, which is the source and sink composite curve, and they have this problem table algorithm, which they call the total site problem table algorithm. But it gives you the same result. Yeah, and if you're interested, you can read this paper by Liu et al. Yeah, so this is actually my PSM student, my first year student that did with me in 2013. Yeah, so for his first year project, he published in this Applied Thermal Engineering Journal. Yeah, and this paper is among one of the highest cited paper out there on total site heat integration. Right, so for total site heat integration, besides you can target, yeah, what are the amount of energy that can be generated by one plant and sell to another plant in terms of heat. It can also be used to estimate the cogeneration system rating. Yeah, so for example, let's say, for example, here, I have very high pressure steam. So I know that I need to step it down to high pressure steam. So I can do my cogeneration system planning. Yeah, so I need to step down from what pressure to what pressure and how much is the energy available that needs to be stepped down. From there, we can estimate the amount of work or electricity, yeah, or power that can be generated by this turbine, yeah, that is used for stepping down this steam. Yeah, so the method to target the cogeneration system or the turbine, yeah, the turbine capacity, the turbine power generation, and so on, you can read in this Clemens et al. 1997. They have quite a good review on the technique. Yeah, so they explain how you can do this targeting for both heat and power integration. Okay. So that was for heat, yeah, for heat and cogeneration system. Yeah, so we have other types of process integration as well. So this one is for renewable energy planning. Okay, so we call the process integration for renewable energy planning the power pinch, yeah, and it uses the concept of hybrid power system. So what is hybrid power system? Yeah, so a hybrid power system is basically you have a set of several potential renewable energy. So for example, maybe in Malaysia, the most suitable renewable energy is maybe solar PV. If maybe you're in a forest and maybe you are near to a river, for example, or maybe a waterfall, you maybe want to consider hydro as well, mini hydro or something. Yeah. So different countries, different locations, you have different potential of renewable energy. Yeah. So like in the case of Germany, for example, or Denmark, They have very strong wind at that area. So the potential renewable energy that they can go for is like wind energy. Yeah, but in the case of Malaysia, wind energy, if you want to do, maybe it's only at the ocean, near to the sea area, yeah, maybe near to the pantai and so on. But it's not really suitable for Malaysia because our wind is not that strong. So in Malaysia, typically the renewable energy that we consider are typically solar, mini hydro, as well as biomass. Yeah, those are the three most famous renewable energy in Malaysia, including biogas. So in a hybrid power system, basically you can look into a combination of different renewable energy, which is available near to your area. Yeah, and you can pair it with either on-grid or off-grid electricity. Okay, so on-grid means you buy electricity, for example, from TNB. Off-grid means you use you're not connected to the grid. Yeah, you're not connected to TNB line, so you have to generate it maybe using a diesel generator. Yeah, you have to generate your additional electricity, which is not enough for your demand, by using maybe a diesel generator. Okay, or maybe other types of system. So in a hybrid power system, you have your renewable energy sources. You have your traditional energy sources, which can be grid or on-grid or off-grid. Yeah, you have a battery, okay, and then you have a demand. Yeah, the demand for electricity. Yeah, so what happened is that, for example, like solar, you have a lot of solar in the morning, but you don't have solar at night. Yeah, so for example, let's say at home, in the morning you go to office, or maybe you go to your school or university and do other things. Yeah, so you're not at home. But let's say you have installed solar PV there. So what happened is, what do you do with that excess electricity that you are not using? Yeah, so if you are not using, this electricity will be stored in the power storage system like battery. And if for example you are at home, so basically you can directly use this solar energy for that demand. But if, for example, at night you don't have solar, so it means that you have to take from the battery. But if the battery is already zero, let's say it's at night time, you already use all the electricity in the battery, is already zero, then you have to take from the generators. Yeah, the generators. You have to outsource the electricity from either the grid or from your generators. Yeah. So this is the concept of hybrid power system, where there is a connection between sources, demand. Yeah, remember, process integration means you require a source as well as a demand. So in this case, your sources are the renewable energy, your demand are your electrical demand. Yeah. And then after that, you need to target your minimum energy target, right? For heat, you have to target the minimum QH as well as QC min. So in the case of hybrid power system, you have to target the minimum amount of electricity that you need from your outsourced energy. Yeah, either diesel generator or maybe your grid supply. Yeah. And for hybrid power system is quite unique because you have a storage system. Yeah. So for heat integration that you learned previously, there's no storage system. Yeah. But there's actually for heat also, there's also, let's say you are doing for batch plant. Yeah. So for batch plant, your heat from one process may be at a different time than the demand of your one process. So in that case, you also need a thermal energy storage system. Okay. So to target process integration with storage system, there's a bit different in terms of their targeting technique, but it's doable and there's a lot of technique on it as well. So you can also read on batch heat integration if you guys are interested on heat integration. So previously you only learned for continuous system, but there's also batch heat integration where they have thermal energy storage. And this one is what we call power pinch, yeah, where you can also see how you can connect the source and demand and the power supply. Okay. So power pinch was introduced by our research team as well. So basically you have a lot of power sources and you have a lot of power demands at different rating. Yeah. And then you can cascade the electricity from one time to the other. And then when you have a negative cascade, for example, yeah, it means that you have to store some of the excess power And if, for example, the battery size is not enough, then you have to outsource the electricity. So from this power pinch, again, we have the numerical and graphical method, and you can target what is the minimum amount of electricity that you still need, as well as, let's say you have a surplus electricity, which you are not using in your battery. So you can bring it to the next day, for example. So this technique is called power pinch analysis, and is being used to do process integration for hybrid power system or renewable energy planning. Okay? So if you're interested in reading about this, you can read these two articles. So these two journal papers. Okay, next one is water. So we talk about heat, we talk about power. Now let's talk about wastewater. So this is, just now it was for supply side planning. How about for our end of pipe planning? Yeah, how do we use process integration? In fact, when we are talking about water, we are actually solving both the supply and the end of pipe part. Yeah, because for example, if you can reduce your water consumption, you also reduce your supply side. And if you can manage your wastewater, it also reduce your wastewater emission. Okay. So how does the wastewater integration works? Yeah, I give you guys a simple example. Okay, so water that we use every day, we don't really need fresh, clean water with zero contaminant for everything. Maybe you need fresh water for drinking. Of course, you need fresh water for drinking, right? But for example, like flushing toilet, do we need to use very, very clean water to flush a toilet? Yeah, no, right? Yeah? So for example, in Japan, like for example, this kid, yeah, so he washed his hand, and then he collect this water from his hand washing inside this toilet flushing tank. Yeah, and then this toilet flushing tank is being used to flush the toilet. All right. So this is one way, what we call water reuse or water recycling. Yeah, not all processes require clean water. Some processes need clean water, like drinking, yeah, cooking. You need very, very clean water. But many other processes inside the plant, they don't really need this clean water. Yeah, like for example, scrubber, gas scrubbing. Yeah, you want to scrub the gas emission, yeah, coming out from a process, or maybe you have a toxic process, you want to scrub that gas. You don't need clean, pure water at your scrubber. Yeah? So scrubber can accept recycled wastewater. Okay? Cooling tower also do not need pure water. Yeah. Some other equipment, yeah, like for example, you use it for heating. So you have a heat exchanger. Let's say you use it for cooling, and you have a heat exchanger where you're not consuming that water. So you just use that water for cooling, for example. Again, you don't need very, very clean or pure water for this, right? So not all processes need pure, clean water. So the idea of water recycling is that not all processes require clean water. And in that way, we can recover or recycle some of the wastewater, which is cleaner. Okay, so I give an example. So like, for example, this process, they have a lot of wastewater. Yeah, so all this line is a wastewater. And previously, all this wastewater, they discharge it to the wastewater treatment plant. Okay, but after that, they discovered that some of this water is not that dirty, so they collected the information on the contaminant. Yes, and from there, these are, for example, the water demand, and you can see that the water demand, for example, here they require water demand for scrubber and boiler. Yeah, so from here they look into possibility of water reuse and water recycling, and we have a water integration technique for that, which we call the water pinch analysis. Yeah. So in total site also, we can do water integration. Yeah. So I give an example. Let's say you have a lot of plant, and some of this plant, yeah, their wastewater is quite clean. Yeah. Maybe for example, like semiconductor plant, their water is actually quite clean, yeah, because they use ultra pure water for their processes to wash their wafer and so on. And then they still have this wastewater. Their wastewater is very small in terms of contaminant limit, but they cannot reuse back for semiconductor because semiconductor require ultra pure water in order for their processes. But other companies can accept this wastewater. Okay, so in fact, inside a company, there are many processes that produce quite a clean water, and there are also several processes that you can utilize this wastewater which are not so dirty. Yeah, of course, we have to see the contaminant limit and the mass load available in all these water sources. Yeah, so again, we have sources for process integration. Yeah, we need to have sources. So the sources are our wastewater with different contaminant load. Our demand are processes that require water, and some of this demand can accept lower quality water. Yeah, so we have a water source with different quality and a water demand that require different quality of water as well. Yeah, so here again, we can do the water integration or water pinch analysis, and we can do for single site as well as multiple site as well. Yeah, so this paper is an example for multiple site water integration. Yeah, so for example, there's several water. So they classify the water into several range of contaminant. So let's say this one, the range for header 1 water, they classify it as the high purity water. Yeah, even though it has some contaminant, but it's within this certain range, but it's still considered as maybe level 1 contaminant level. Yeah, and then they have this level 2 contaminant level for header 2. So let's say some of these processes, they can generate this, they have this wastewater which is clean, so they can inject that wastewater into either this header 1 or header 2 based on the contaminant limit. And then maybe some plants, they can utilize this wastewater, which is not, which have a bit of contaminant, but still not that dirty. So they can take this water from this header. Yeah, so instead of buying fresh water, like for example, in Johor, we are using fresh water from Syarikat Air Johor. Now they can also buy this second grade water, yeah, from this header. Yeah, so this is what we call the total site water integration, where companies can also exchange their water with each other so that you can reduce the amount of fresh water being used. Yeah. So again, you can read this paper if you're interested on this technique. Okay. Any questions, you guys? Okay. Yeah. All right. So for those that haven't registered your attendance, the attendance is open. Yeah. So please make sure you register your attendance as well. Okay. All right, next one is for CO2. Yeah, again, we're going towards net zero, right? So that's why we are looking into all these type of various resources. So let's look into CO2 integration now. So how does CO2 integration works? Yeah, again, you need a source and a demand. So the source is the CO2 emissions from various sources in your plant. Yeah. So in the case of your plant, for example, most of your CO2 either comes out from your reactor, or it can also come out from the combustion process. Yeah. So for example, you need to produce steam. So you have a boiler. So you are burning natural gas, for example. So you have your CO2 from your combustion process, right? So you can see here, there are a lot of sources for CO2 emissions. It could be from the stack, it could be from your cogen, it could be from your gas turbine, gasifier, and so on. And this CO2, there are also different composition. Some are higher CO2 composition, some they have also other gases. So for example, in a combustion process, you don't have pure CO2 coming out from your stack. Yeah, you also have unreacted oxygen, you have H2O, you have nitrogen, you have NOx, you have SOx, right? SOx and NOx. So in that case, typically the CO2 coming out from your flue gas stack, yeah, resulting from your combustion process is not typically pure. So if you want to utilize this CO2, you have to either utilize the CO2 to demands that can accept this CO2, which is not pure, or if some of the demands require pure CO2, then you have to capture this CO2 and then you have to clean it first, yeah, using scrubber, yeah, and so on, before you can utilize it. All right. So you can see here, these are some possible CO2 demand company. Like for example, you can use in a beverage plant, yeah, like for example, Coca-Cola, Pepsi, and so on. They require CO2, right? Because it's a gas drink. Yeah, but of course they require quite a high purity CO2 for this purpose. You can also use CO2 for enhanced oil recovery. Yeah, so how does enhanced oil recovery works? Basically, you inject the CO2 underneath, and then you use that gas to push the oil out from the underground. All right, so that is enhanced oil recovery. Basically, they inject the CO2 underground to push the oil out, and at the same time they store the CO2 underground. Okay. You can also use CO2 to produce methanol. Yeah, that's what some of your companies, some of your Verbund plant are doing, right? You are converting CO2, for example, to methanol or other products. And another way is for microalgae cultivation. Yeah, nowadays people cultivate algae, yeah, because algae, one is it can absorb CO2. Second, you can produce biodiesel from algae. Yeah, so sometimes people they rear this a lot of this microalgae, and then after that, this microalgae can also be used to produce energy, actually. Yeah, so there's a technology to produce energy from algae. You can read this technology. It's quite interesting as well. Okay. So in a CO2 integration, basically you have to identify. So let's say in your Verbund plant, you have several plants. Maybe you have your own combustion and so on, or maybe your combustion is from your centralized utility system. And there's also CO2 being generated by your other companies, yeah, inside your Verbund team. So you can identify what are the flow rates of those CO2 and the CO2 composition. Yeah, so how do you identify this CO2 composition? You have to look at what is the process. So if it's a combustion, so you have to check what is a typical CO2 amount in a combustion process. Okay, and then the CO2 demand. So you have to see. Yeah, so that's the reason why we ask you guys to have a CCU, carbon capture and utilization planning, in your first Verbund part 1 last semester. Yeah, and to also identify a company that can convert your CO2 into a product. Yeah, and then the next thing is you have to consider enhanced oil recovery. Yeah, maybe sequestration. Maybe you can plant trees, for example, that can absorb CO2. Maybe you can consider microalgae cultivation. So you need to plan what are the demands that can absorb this CO2. Yeah, maybe if there is a nearby EOR, enhanced oil recovery, like Kawasari, if it's nearby your Verbund plant, then you can send it there. And so I heard Sarawak also have their enhanced oil recovery planning. I'm not sure what is the name of their area, but for West Malaysia, I heard it was Kawasari, but maybe there's more other upcoming enhanced oil recovery system being met nowadays, yeah, by Petronas and others. Yeah. So this is CO2 pitch. Again, you have, this is your CO2 composite. This is your demand composite curve. Yeah. Again, it used almost the same concept, a composite curve, a problem table algorithm. Yeah, a composite. And then it always identify a pinch point. And from there, you can identify what is the CO2 emission that you have reduced. Yeah. So imagine before this, all these sources, yeah, all these sources, they are emitting CO2 to the environment. Yeah, so imagine all this gasifier, stack, and so on. Previously, you just emit the CO2 to the atmosphere, which is causing our climate change, right? But now, if we have this demand planning, then this source can absorb this CO2 and maybe utilize it or sequestrate it. So in that case, you reduce your CO2 emission. So the CO2 emission has drastically been reduced. And in the case of this, for example, let's say before this, I need to buy pure CO2. Yeah, maybe I need to produce pure CO2 from a plant, and then I need to generate that CO2, produce it, and then purify it in order for me to use. Now I only need less CO2 that I need to buy from the market because I'm using the waste CO2 coming out from my other plants. Yeah, so this is what we call carbon emission uh, integration. Okay. So again, you can read this paper. So if you're interested, we have a lot of paper in this pinch analysis for targeting CO2 total site planning. Okay. Okay. The last type. So as I have mentioned, there are a lot of process integration method. I'm not going through all. I'm giving you guys a flavor of the different type of process integration which is relevant to eco-industrial park planning only. Okay, so the last one is I would like to introduce the waste integration method. Okay, so waste is being generated by industries. Yeah, so I give example of waste. Yeah, we have paper waste, we have plastic waste. Yeah, so for example, let's say industries, they buy their raw material. So the raw material comes in boxes, for example, or plastic bags. Yeah. And for example, you have organic waste, metal waste, yeah, glass, maybe some comes in glass. Yeah. So you have hazardous waste, and let's say you have a wastewater treatment plant, you also have sludge waste and other types of waste. Yeah. So there are a lot of ways we can manage this waste. We can send everything to landfill if it's not hazardous. For hazardous, of course, you cannot send to landfill. We can also incinerate this waste without generating energy, or we can also do incineration and recover the energy. Or another way is we go for 3R, yeah, reuse, recycling, and reduce. Yeah. So the first is always to prioritize 3R, followed by waste to energy, and lastly to go for landfill as the last resort. Okay. So all these waste, actually, you can also convert it into carbon emission factor. So these are some example of carbon emission factor. If you landfill it, this is the amount of carbon being emitted. If you change it to energy, this to waste to energy, these are the emissions, and these are the 3R. Yeah. So by using the waste management page, yeah, so basically you can target, let's say the government has imposed, yeah, that we have to reduce 40% of our CO2 emission inside our area. So what happened is, let's say now you are landfilling, yeah, you are landfilling most of your waste, and some of it you are incinerating. Yeah, so this is the amount of CO2 emission being produced by maybe that industrial park at that area. So government say you have to reduce by 40% of your CO2 emission, and this is the new CO2 emission that you have to reduce. So you have to employ the 3R strategy, waste to energy, and other types of technologies available. So you can see here what they do is that to reduce this carbon emission, so this is the existing 3R. So basically they do more 3R, and then after that they converted more into waste to energy. So in that way they managed to reduce their carbon emission from this much, yeah, 600 plus ton per year. They managed to reduce it to 100 plus ton per year. Okay, so this is called waste management pinch analysis. Okay, so these are the paper if you're interested. Okay, so those are the types of integration method that you guys can look at. Yeah? I have introduced you guys the total site heat and power integration technique. I have introduced you guys to power integration technique for hybrid power system. I have also introduced you guys to wastewater, yeah, water pinch analysis, as well as waste pinch analysis and CO2 pinch analysis. All these 5 types of pinch analysis, you can use it for your eco-industrial park planning. Maybe not for this project, but maybe if you guys are doing it for a real industrial project in the future, right? So all this type of pinch I have introduced previously are piecemeal. Yeah, you do for CO2 only, you do for carbon, you do for heat only, power only, right? So are they systematic ways? Which one should you implement first? Which one should you implement second? Yeah. So how do you implement all the various type of resource integration method that I have mentioned previously in order to develop your eco-industrial park towards net zero emission? Okay. So this is where you can do the integrated resource planning for eco-industrial park. Yeah? And using the simple concept of pinch analysis where you can just use graph or numerical technique for it. Yeah? So you can see here in an integrated eco-industrial park planning, you have your centralized utility planning for steam and power. You have the exchange of heat, power, yeah, and even waste, yeah, among industries. So you have your 3R, you have your waste to energy system, and then you have your remaining waste that you need to landfill. Yeah. And here, after you have already, and here you can see the water header, yeah? The water header where they're also exchanging their wastewater, yeah, with each company. Yeah, so you can see here in an integrated eco-industrial park planning, you can do demand planning for heat, power, water, and waste. Yeah? So heat recycling, heat exchange, waste exchange, and so on. And then after that, you can also plan for the waste to energy. So this waste to energy, let's say you generate some energy from this waste to energy system from your incinerator, for example. So you reduce the amount of maybe fuel that you need for your steam system, centralized steam system. So here you have your centralized power system, and the remaining CO2 that is still being generated by your whole plant, you need to think about sequestration. Yeah, so always remember to follow the carbon management hierarchy, avoid, reduce, yeah? And then after that you have to sequestrate, and finally, if you cannot reduce anymore, then you have to go for offset. Yeah, so that is the idea where you can implement all those various type of pinch method that I have introduced previously. Yeah. So this is again one of my PSM student in 2021. It was 2 years ago. Yeah. So she published this paper with me. So basically, she did a comprehensive framework on how to use all the pinch technique systematically. Yeah. So in her study, she mentioned that first you have to know what are the amount of waste available in your eco-industrial park and how much of this waste can be going for 3R, converted to energy and being landfill. And then from there, she do the total site heat integration. After she do total site heat integration, she do the cogeneration potential analysis using the method I showed just now. And then after that, she did the renewable energy planning or hybrid power system, yeah, using the power pinch technique just now. And after that, she planned for the remaining centralized utility and power system. Yeah? So after she has integrated and exchanged the resource among the industries using this various type of resource integration technique, then she do the centralized utility and waste system planning. Yeah. And after that, there are still CO2 being emitted from the centralized system. So she do the CO2 emission pinch analysis at that point. Yeah, from the CO2 emission pinch analysis, she identify what kind of plants that can absorb the CO2 or utilize it, and what kind of sequestration that she needs to plan. Okay, and then from there, she determined the amount of sequestration that she needs, and finally, she also determined the amount of centralized water reuse. So this was the technique or the framework introduced by my student. Again, she was just a PSM student, just like you guys, not a master student, not even a PhD student. So actually, if you work on this kind of project, you can also solve it even if you're undergraduate students. Yeah. So as a final say, university, especially, there are not many experts in this area yet. Yeah, that is the reason why we are trying to introduce all this to you guys. It might feel a bit tough because you guys are not doing a normal plant design project. But believe in me, if we don't start to train any of the new generation in this area, yeah, we will be left behind by other countries all over the world. Yeah, Germany is going in this direction. China is going in this direction. Indonesia, even our very nearby country, they are more advanced than us now. Yeah, so if we don't train or don't introduce this kind of knowledge to our students, then it will be a waste for us. Yeah, so that's where university's role is very important, and we hope that you guys will be the next generation that bring this kind of technology, as well as bring all the industries that you guys will be working on to this net zero emission direction. Okay. Right. So as a conclusion, my take-home message is that this is timely for industries within an industrial site to work in synergy. Yeah? We cannot work alone anymore. Climate change is real. Yeah? You can see all the floodings happening, all the heat waves happening. Yeah? If we don't work in synergy, we cannot achieve the net zero emission target. Yeah? We have to work in synergy. If not, it's not going to be possible. Yeah, and eco-industrial park is one of the direction. Yeah, instead of just working in silo, every company, Petronas work alone, BSF work alone, for example, or Nestle, everyone work alone. It won't help the global scenario. Yeah, that's why we have to think how to work in synergy with also other industries nearby. Okay, we don't only want to reduce the environmental impact, but actually, if like I mentioned just now, if you go for this eco-industrial park with industrial symbiosis and circular economy, actually the benefit is not only you reduce your emission, but you can also generate income. Yeah, so for example, you produce steam from your plant, which you can sell to the header. Yeah, so that is actually income generation where you are producing steam from your waste heat that you need to cool down by using water. Before that, it's an operating cost because you have to cool down that heat by using cooling water. Now it becomes income generation because you can generate steam and sell it to other plants. So same thing, electricity. If you just produce for your own company, then you just save for your own company. If you sell it to others, it becomes an income generation. Water also, if you have quite a clean water coming out from your process, but you cannot reuse it for your own process. So if you treat it until fresh water level, then it will be very expensive to have all the water treatment process. But if you sell the lower quality water to maybe the next plant, next door, for example, again, it's income generation and you require less investment. Yeah. So circular economy and industrial symbiosis can actually create what we call the green economy. Yeah, we call it the green economy or the green growth economy. Yeah, in fact, the Malaysia EPU, yeah, Economic Planning Unit, yeah, we worked with them also a few years back. They developed this green growth planning, yeah, where they foresee that one of the way that Malaysia, yeah, can move towards reducing our environmental impact is also by looking into how we can create this green economic growth that can also generate income, yeah, for companies by selling this waste and so on. Yeah, and we can also create job creation and so on in this new area. Okay. So universities should play a big role, and we also hope that industries, they can take up this technology, yeah, and bring it to reality in the future for Malaysia, right? So I think that's all for my talk today. So do you guys have any questions on that? So I open for Q&A now. Come on, some questions, please. So are you guys listening or are you guys sleeping? Okay, any questions? Okay, if there's no question on this talk, please don't forget you have to summarize. Okay, there's one question from Sim. Thank you. Okay, how we can promote this kind of process integration, industrial symbiosis to local company, because this technology is still new and expensive. Yeah, right. A very good question by Sim. So process integration typically will promote for single site first. Yeah. So normally like what I do before this, I typically pitch to companies. Yeah. So that's why we did a project like me myself. I have done a lot of projects. Yeah. I have done for Shell, Pertamina, palm oil companies, semiconductor plants, and many. So in the first place, normally we pitch for single site first. But as I have mentioned nowadays, there is an effort by CIRIM, yeah, to promote industrial symbiosis. So now I'm also working with CIRIM to promote this industrial symbiosis, and that's why we did a project for eco-industrial park planning nowadays. Yeah. So how can we promote this? First of all, you have to create awareness for your site first. Yeah, at least resource, yeah, how to go net zero first within your site. Secondly, if there is a planning, yeah, by your industrial site, yeah, let's say your industrial site within that area is also moving towards eco-industrial park, then your company can contribute towards that direction. Another way is, do you know Kalunberg that I mentioned last time? Actually, the companies, they talk to each other. There was no government at that time that helped to create the eco-industrial park for that Kalunberg case. So the Kalunberg industrial people, what happened is that there are several companies, so they are very close to each other. Maybe they meet in the cafe, maybe they meet in some of the, maybe they eat together. Sometimes they do sport day together among industries. Yeah, sometimes. So normally what happened is that some of these industries within some industrial site area, they have this community among industries. Yeah. So this community, sometimes they make sport day, they make others. So at that time, that is when sometimes they talk to each other. Oh, my company have this type of waste. My company have this type of things. My company needs this. My company needs that. And from that, that is where Kalunberg, they become what they are now. Yeah? They were the first eco-industrial park, and it was done solely because the companies communicate with each other. It was by their own effort, not by the government. Yeah. So you guys can also do that. Yeah. So for example, let's say you have nearby industries. Sometimes you just need to talk to each other in order to initiate it. And then you just need someone that can persuade your top management. And then from there, you can already plan how you can exchange the resources and so on. The technology is, it may be expensive, it may not be expensive. It depends. Yeah, sometimes, for example, if you need to send a wastewater from one plant to the other, let's say it's just next door. The only cost that you need is a piping and pumping. You don't even need to install a new boiler or anything. Yeah. So maybe you cannot do everything that I have mentioned immediately, but you can do some of it. Yeah. So for example, like water. Let's say the first thing that you notice is you can exchange water. So you can do that first. Yeah. So in terms of investment, it can be bit by bit, right? So that's for SIM. Okay, Tan Yong Seng, thank you. Prof, the plant integration was to reduce operating costs. But is it a must that the cost will be reduced? If we face an increase of costs, what and how should we tackle this issue? Right? So typically there will be a trade-off. Yeah? Typically there will be a trade-off. For example, let's say you recycle. Typically in most cases, yeah, the operating cost will reduce, but maybe you need some capital investment. Yeah? So for example, maybe you need to invest in new technologies and so on. That is where you need to do economic and feasibility analysis. Yeah, so typically many plants, you have to do the feasibility analysis, and if it's a positive economics, then we proceed with it. Okay. Okay, some more questions. Okay, Ibrahim. Okay. Can CO2 be used as condition stabilizer? For example, as inert in processes instead of processing to different products, because that will emit even more CO2 if we take the whole production cycle into consideration. Okay, so condition stabilizer as inert instead of processing to them, because then we okay, so you're saying that condition stabilizer, what do you mean by condition stabilizer, Ibrahim? Because typically there are several ways you can sequestrate the CO2. One way is you can also convert it into solid material, yeah, where, for example, that solid material, maybe you embed it under the sea or something. So there's also people that talks about this, yeah. It's true that sometimes if you utilize CO2 for producing another product, in the end, the CO2 will again be released again. Yeah. So for example, like hydrogen production. Yeah. So people say they produce hydrogen. Yeah. From, let's say so hydrogen production, there are many pathways to produce hydrogen. Yeah. So they have this gray hydrogen production, they have this green hydrogen production. So they have many pathways to produce hydrogen production. So the gray hydrogen production, for example, they produce hydrogen from natural gas or the normal fuel. Yeah. So basically they generate this hydrogen, and then after that they still emit CO2 at the same time. Yeah. So in this case, if we look at this, sometimes it depends. You have to look at the net CO2, and sometimes if you absorb this CO2, maybe after that it's being released at a later stage. Yeah. So you're right. Normally, we have to take into the overall production, and that's why people conduct life cycle analysis. Yeah, so typically, that's why nowadays, when people are doing this analysis on whether it's a net surplus, is it a net benefit, or actually it give you a negative benefit. So you have to look it from life cycle angle. Like for example, solar. Yeah? People said solar PV is green. Yeah. But when they do look at the life cycle analysis, yeah, the chemical of the solar PV, to produce solar PV, you need to use special material. In terms of disposal, yeah, maybe the emission is even worse, for example. So that's why we have to look from the life cycle analysis angle. Okay, okay, I have a question from Husna. Previously, Prof mentioned no need to use fresh water for scrubber. Okay, but isn't it will affect efficiency and need frequent maintenance? So are there any alternative methods and technologies available that minimize the need for fresh water and still ensure efficient operation with reduced maintenance costs? Yeah. Okay. Again, if you use recycled water, it depends on what type of contaminants is inside there. So for example, if you have organic compound in your wastewater, especially, so it might lead to, for example, bacterial growth and other things. Yeah. So it's just like swimming pool. A swimming pool. You guys, how many people use that swimming pool water? Yeah, maybe that swimming pool, they change the water only 2 or 3 days once. And like how many people swim in the swimming pool, right? So in that way, they put chlorine tablets, right, in the swimming pool so that you can still reuse that swimming pool. So swimming pool is not once off water. You don't use that water once, one person only swim, and then after that you change the whole water for the second person to swim inside there. So you put like a chlorine tablet, and if you notice in a swimming pool, they have a pump which have a water purifier where they circulate the water and then they filter it. So the water in a swimming pool, they can last like for several days before they need to change the water. Yeah. So same thing, if you are recycling wastewater, there are ways also where you can, for example, you can what we call regeneration. Yeah, regeneration means you don't treat or purify everything until zero contaminant. You purify it until certain level of contaminant. Yeah. So for example, in the case of swimming pool, you need to remove the bacterial, right? You don't want to have bacteria from other people swimming in the swimming pool. Yeah, you don't want to get infected and so on, because many different types of people swim there. So one way is they control the pathogens, yeah, inside the swimming pool by using chlorine tablet. So same thing for reusing water. Basically, you can pre-treat the wastewater to remove some of the things and to ensure that you can reuse and recycle that water. But as you have mentioned, of course, there's some maintenance costs. Yeah, swimming pool also, you cannot use it all the time. You still have to change, for example, every 3 or 4 days. So same thing. If you have a reuse and recycling system, sometimes you need to clean it. And for example, let's say you have a water filter, you can do backwash, for example. Yeah, so that is one way they do the cleaning. Yeah. Okay, Leong. What are the efforts or initiatives to encourage the industry in Malaysia to move towards process integration? Yeah, and what is the biggest challenge facing by the industry to move towards this direction? Okay, okay. What are the effort or initiative to encourage? One of it is normally it has to start with the government. Okay. You can see from the news article that I showed just now, government is moving towards this net zero emission direction. Okay, but government cannot just say you have to go net zero emission. They have to put some regulations. They have to put some acts. They have to maybe remove the subsidy. You know, they have to like give some tax. So they have to do something in order to drive the industry towards this direction. Yeah. So one of the way, for example, yeah, if you guys read the latest news, they say there will be no more electricity subsidy for rich people, right? So what is the reason that they removed the subsidy of electricity for rich people? Is because they want the rich people to install solar PV at their home. because they know that these rich people, if the electricity bill increase, so they don't have other choice. So if, for example, the electricity bill remain low, being subsidized for everyone, then this uptake for this green technology people will not do it. Because if, for example, our electricity is cheap for industry, our fuel tariff is cheap for fuel, water tariff is also very cheap. Water in Malaysia is very, very highly subsidized in Malaysia. So if, for example, the government starts to lift off this subsidized 111, industries will be forced to go towards this recovery, resource integration, and so on. So it's only time now. As you guys see in the news now, one by one, government is removing the subsidy already. And I believe in the future, government will also introduce carbon tax. Singapore, for example, they are taxing the amount of CO2 that you emitted. So for every amount of CO2 that a company emit, there will be tax on that CO2. So because of this carbon tax also, many industries in Singapore, they are moving towards green technology like process integration and so on. So of course, the biggest challenge is investment. If companies, they want to move towards this direction, is typically investment. But if our operating cost is high, at that time, normally industries will consider investing in this kind of technology. Right. Any other questions? Okay. So if not, please don't forget to summarize what you have learned from this talk today. And just to remind back, what are the deliverables for you guys for the Verbund project? So you guys should already start to do, this is week 10, right? Week 10. And next week is already week 11. So week 11, you should already start on your Verbund part. So I hope each design team, each Verbund team, you already have a meeting and you have already divided among your design team who will be doing which centralized utility and waste treatment system. So remember that as a Verbund team, first thing, identify first what are the waste and utilities generated from your design team within your Verbund plant. The next thing is which one should you do centralized, which one should you do individual within the plant itself. Maybe let's say they have a gas hazardous gas, but other plants doesn't need it, so they can just do the treatment within their own plant. So as a start, you have to identify and just mention which one should be done centralized, which one should be done within that single plant. How do you manage those emissions? Secondly, once you have decided which one should be done centralized, divide it among your design team. If you want, for example, let's say for CO2, for example, you want to have two teams looking at CO2, but maybe at different direction or different pathway. That's also possible. So try to plan what kind of centralized utility and waste planning, but different utilities and different resources for each of the design team. Okay, so what does the design team have to do? They have to do technology review. So for example, let's say you are tasked to look into steam thermal energy generation. You have to supply steam to all the plants. So what you need to do is first identify what are the steam levels needed by all the plants. How much do they need? What are the steam levels that they need? And then let's say you want to do together with cogeneration system, also the electricity amount. So from there, you need to read about cogeneration system. What are the components of the equipment inside a cogeneration system? So you need a boiler, and then you need, for example, you need boiler feed water. So to produce boiler feed water, so you need a deaerator, for example, and then after that, you go into the boiler. The boiler will produce steam. So the steam will be sent to your processes. So before it being sent to the process, you have your PRV or your turbine. And then after that, you have your condensate return. So you have to draw the whole cycle of your steam system, from boiler up to condensate return. So what are the equipments that you have within that centralized boiler system. And is it going to be one boiler, or maybe you have multiple boiler if it's a very big capacity that you need to produce, right? So you need to do simple mass energy balance. You don't need to do simulation. Yeah. So for example, you can just use a rule of thumb. So for example, let's say you're using natural gas for your boiler. So what is the efficiency of your boiler? You can just assume like maybe 85% efficiency of your boiler. And then let's say turbine. Yeah. Turbine, maybe the efficiency is 45%. So what will be the electricity produced? Yeah, and then from there, you just do the mass energy balance using those types of values. Yeah, so you need to draw the flow sheet and other things. So you need to do technology review as well. Maybe there are different technologies of steam production or cogeneration system. So cogeneration system, you have the option of steam turbine or gas turbine, for example. So you may want to explore the different types of cogeneration system available. Okay. So basically, you have to do this technology review. So same thing, if you're doing for water or other types of utilities and resource system. So once each team have already come out with this, yeah, they come out with the design, so they have come out with the centralized system. So each team has to do their sizing and costing. So estimate the price of your centralized utility system, and then go back to your Verbund team and gather back all the information. Yeah, so now you have done the sizing, costing, profitability for each plant, as well as for the centralized utility and waste treatment plant. Okay, so analyze as a whole Verbund plant. What is the total cost for the whole Verbund plant? Okay, and you can also assume what if you don't have Verbund previously. Yeah, so for example, let's say some of the plant, instead of they purchase the raw material from another plant, let's say they buy it in the market. What would be the difference in price? And what would be the impact on the emission as well, environmental analysis. So the environmental analysis, for example, you can calculate the CO2 emission with and without Verbund. Again, this one, you can just use some assumption. You don't have to design a no Verbund plant from scratch. Yeah? You just need to do some assumptions and some rough calculations for this. Okay. And after that, you have to design your Verbund site layout. So let's say you have your value chain, right? So which plant should be put next to each other? Where should you put your centralized wastewater treatment plant? Where should you put your centralized steam system? Yeah, so based on the demand and thinking how the flow of the energy, water, and so on. So you can do planning for your Verbund site layout. Okay, so basically that is the thing that you need to do for your Verbund plant part. Okay, any questions on this Verbund? Okay, there's another question from Leong. May I ask, is it for the centralized waste system, it only treat the waste that is not hazardous or toxic, like wastewater treatment? If there is toxic or hazardous chemical waste, the design should treat it inside the plant. For waste, hazardous waste, typically we send it to, for example, like in Johor, we send it to Quality Alam. Yeah. So waste, you can also send it to other companies. Yeah, basically you can sell it to other companies, but that company has to have permission. Like for example, Quality Alam, they have a special incinerator that can incinerate this hazardous waste. Yeah. So typically is the gas that you have to treat inside your plant, because solid or liquid hazardous waste, you can still send it to Quality Alam and so on. But gaseous gas, yeah, normally you have to either incinerate in your own plant or you have to flare it. Yeah, so if it's a lot and it's very toxic, normally you have to have an incinerator inside your own plant. That's for gaseous gas. But for liquid and waste, solid waste, you can still send it to for the treatment or for the disposal. Okay. Any other questions? Okay, Sim. For clarify, okay, all design team have to do a pre-treatment plan first, then send the wastewater to this centralized waste system. Pre-treatment, is it for the waste or the wastewater? What are you talking about here, Sim? Maybe you can clarify to me on that. Aiman, Prof, for centralized utility system, some company doesn't recycle back the steam to the boiler feed water. If possible, you want to recycle back your condensate. Yeah. So for example, let's say you generate steam, you send it to the plant. If possible, you want to collect back the condensate water return. That will be the best, unless the amount is very small. Then you don't collect back the water, but then maybe that water, because it's still clean, you can consider water recycling. So let's say you don't collect the water going back to your boiler, maybe you can collect that water and consider water reuse and recycling. All right, so maybe you have a connection with your other design team as well. All right, so Sim, you were saying is for the wastewater. Pre-treatment plant. Yeah, so wastewater treatment, normally we have primary treatment, secondary treatment, and tertiary treatment, right? So for wastewater, you have several options. As I have mentioned just now, if you can do water reuse and recycling first, that will be the best. Yeah. And then after that, you collected the wastewater before you send it for treatment. Yeah. So for the centralized wastewater treatment, you can do some preliminary treatment, like maybe the primary treatment first, before you go for secondary treatment and so on. Yeah, you can do some pre-treatment. It depends on the condition of the wastewater being generated. Okay. You guys have heard the talk, yeah, by I think there was 2 talk before this, right? By someone doing centralized utility and centralized waste system. You can also ask them. They have the actual plan being implemented for their site. Okay, I think it was Casey. Yeah? Casey was my friend also last time when I was doing my postgraduate study. Okay, any other questions? Can also switch on your mic if you want.
Sorry, Doctor.
Yeah,
I
no
have
worry.
a question
Sorry.
that
Yeah, go
I
ahead.
think for every design team, they have different type of wastewater produce. So according to Dr. Casey, for the waste centralized waste treatment wastewater treatment plant, they have a significant what we call requirement for the wastewater to be treated at the centralized. So if each design team has different quality of design water, uh, do we need to do the pre-treatment first in our design team before the wastewater can be released to the can be sent to the centralized wastewater treatment system?
Like I mentioned just now, the what you can mention it in your Verbund plan that okay, what are the wastewater produced by each of these design team first, and then let's say you assume some pre-treatment before you send to the wastewater treatment charge. You don't have to design the pre-treatment for each of these plant because we're not designing single plant. But you can assume that after this pre-treatment, this is the quality, and then this is the amount being sent to the centralized wastewater treatment. But you have to at least advise what are the pre-treatment that needs to be done by that single plant. But you don't have to design for that single plant because you guys are doing the centralized system part only, right? But you can mention in your report about the pre-treatment that will be required. Okay?
Yeah. Okay, so we only have to mention in our report that we don't need to design for our
You
own
don't
design.
need to design for each of that single plant, but you can mention these are example of the pre-treatment needed. But the focus should be on the centralized part.
Okay, that's it. Understood. Thank you.
Okay, sure.
Prof,
Any other? Yeah.
hello, Prof. So may I ask for the centralized system, right? So we just only design the centralized, so means that we only have the one TSC.
Sorry, Sim, can you speak louder?
So for the centralized system, is we only have one process flow diagram for that, right? No need like five, like combine five of our DTs and do a centralized system. Just one centralized system.
It's one centralized system, but you are serving the companies within your Verbund site. So you're not designing for a single plant. You're designing, let's say there's 5 plants, but maybe not all will send to that centralized. So you're designing for how many that you are taking, but you have to design for that capacity lah.
Alright, so we only have one PFD diagram for the centralized system, right?
One PFD for central. If you design, each design team will have one PFD. Let's say one design team is doing for the centralized wastewater treatment plant. So they have their primary treatment, secondary, and so on inside their PFD. Yeah, they have their clarifier and so on. And let's say another team is doing the steam system, so they have their own PFD. So each centralized utility system and centralized waste, they will have a PFD. But after you have done technology review, then you say which technology you are using, then you make that PFD and the mass energy balance.
Oh, alright, thank you, Prof.
Okay, sure. Okay, any other questions? Okay. If there's none, feel free to contact me if you guys still have any questions later on. So I think that's all for today. So thank you very much and all the best for your design project. I noticed that some of you are quite late already in your deliverables. So please beef up your progress and you should start on your Verbund plant side simultaneously. So even though you're not completed your design team's part, you can already work simultaneously for your Verbund part as well. So please make sure you can deliver on time before the presentation. All right, so please observe the timeline inside the Excel given in the Google Drive. Okay. Okay, no other questions? All right, so if that's all, thank you very much, everyone. So all the best. So you can use the time during the seminar for this week for your Verbund team discussion. Yeah, so maybe you can set a time among your Verbund team if you haven't decided on who will be doing which centralized system. But if you have already decided, then you can already work in your design team on the technology review and so on. Okay. All right, that's all for today. Thank you very much, everyone. Okay, Assalamualaikum.
Thank you, Doctor.